Okay, I meant to videotape my class this morning, and that would have been much smarter, but of course I wasn't thinking about it. I was just thinking about getting through the course. So, eighth graders are going to be doing a paper towel lab, whether you're blended or you're virtual. Um, Coach Carroll will designate how he wants his class to do this, but at least you'll have videos to go along with it. So, basically, I'm going to read through this. Paper towel testing. The purpose is to practice the skills used to design experiments. Many brands of paper towels claim that they are the strongest. Research is needed to determine which brand of towel really is the strongest. Since paper towels are usually wet when they're being used, the wet strength of the paper towel is important. Wet strength is the strength of the paper when it is wet. This can be measured by the amount of mass that a wet paper towel can hold. Now it says mass. You'll see that again in a little bit. Mass is something that stays the same regardless of where you're at on the planet or off the planet if you happen to be doing this experiment on the moon or something. But weight is dependent on gravity. So that's depending on how much, if you get on a scale, how much you weigh multiplied by gravity, that would give you your mass then. So, but it is dependent on how far above the center of the earth you are. So if I'm on Everest, I might weigh a little different than I would if I'm closer to the center of the earth, like say down in Mariana Trench or wherever is the deepest place on the planet, bottom of the Grand Canyon, somewhere like that. So just throwing that in there. To design, the task today is to design an experimental investigation, a fair test. In order for something to be a fair test, it must be repeatable and it must be testable. So it must be able to test this particular experiment, this problem that we're about to face, or this observation we're going to make. You want to be able to test, and it should be repeatable. So your neighbor should be able to take the same procedures and replicate it and come up with similar results. All right, so must do an experimental investigation to test the strength of 3 different brands of paper towels. You will have the same materials to conduct, or these materials to conduct the experiment. So if you're here and you're in my class doing this, you're going to give 3 brands of paper towels, water. We're not going to use a graduated cylinder. Have washers, paper clip, triple beam balance, ruler, plate, and tape. So I'll tell you how much water we're actually going to be utilizing. 3 drops is all we're going to use for paper towel. So don't know why we actually need a graduated cylinder. Okay. Identify the variables. So what the independent variable for this experiment, what you will change or the difference between the groups. I always explain independent variable as the thing the scientist is changing in the experiment. So if we're looking at 3 paper towels and which one of them is stronger, has the strongest wet strength, then our independent variable, the thing the scientist is changing, is the paper towels. Obviously, brand A, brand B, brand C. So this blank here is for you to type in the 3 brands that we're using: Bounty, Brawny, and finally, let me get my light back on. Brownie, Brawny, and Viva. Viva Las Vegas. All right, so Viva. All right. Dependent variable is the thing that is changed by what the scientist is changing. So that whatever I'm changing as my independent variable, the thing we're changing as a result of changing that independent variable. So in all cases, it's what we're measuring. So what are we measuring here? We're measuring wet strength, how much the paper towel could hold. All right. So it says right here, what you observe or measure, the data that you will collect. What is a dependent variable in this lab? So answer that right there. Next thing is write a hypothesis. I should have put that on the next line. Sorry, I didn't notice that. Write a hypothesis that shows the expected relationship between the 2 variables. Use an if-then statement. So this is it's not difficult. It's just different for you to think about. So we have 3 paper towels: Bounty, Brawny, and Viva. Which paper towel is the strongest? So you're going to look at the paper towel and you're going to they all are similar. They're all white. They all have same texture and the same feel, but they're three different brands, three different companies. You're going to say, if I have three paper towels, then one of them, whichever one you choose, will be have the strongest wet strength. So you come up with your if-then statement. Now, in experimental design, you are usually creating your experimental test, how you're going to test your hypothesis. In this particular case, I'm giving this to you. All right. No idea why that jumped into a different font. But normally, during the experimental design process, you'll create the procedures. Not so here. So these are the procedures. So you're going to cut 2 centimeters by 28 centimeters of paper towel. That is roughly this length right here. That is that length right there. You're going to tape a paper clip hook at one end of the paper towel and tape the other end to the lab table. I'm going to show you real quick. So just real fast, if I can find it. Here's my paper clip. If you'll notice, it's going through the paper and then it's taped. You can see the reflective. It's taped around it. So in my past experience, I've found it causes a lot less headache if I puncture it through it and then tape around it. If I just put the paper clip on it and then tape around it, as I add weight, the paper clip will slip off. And then you get really disappointed because you do all this work and then it just falls off instead of the paper actually breaking. You're going to put 5 drops of water in. You're going to put 5 drops of water using a pipette on the paper towel. So I'm going to do 1, 2, 3, 4, 5. 5 drops of water right in the center, right there. And you're going to create a point of weakness right there. You're going to do that for all of them. You're going to do this one at a time. No reason to do all 3. Now, my advice to you is only test one paper towel at a time. I labeled this one A, and then I'll do the other one B and the other one C. I made a little hook out of a paper clip like that, and then I'm going to start stacking washers after I tape this somewhere. But I'm also going to use a paper plate like this to catch my washers. So whenever this breaks in the center, I'm going to catch the washers, and then I'm going to transfer the washers to a scale. So for those of you at home, or those of you who are maybe doing this in a virtual type of format, I will provide you the data so that you don't have to do this. You can just input the data and then interpret your data, because that's still basically the same thing. I apologize for not being able to do it. You're going to record your data here. So trial 1. So trial 1 will be one particular student. Trial 2 will be another student. Trial 3, another student, 4, 5, and 6, so on. And then I get an average. We need that average because some students might have errors, and I'll talk about that in a second. Then you're going to graph your data. Create a bar graph of your data. Do not forget, all graphs need tails. Again, tails stands for your title, your axis, your intervals, your labels, and your scale. So I need to know whenever you create a title down here, and if you read, it says our class will complete this on a Google Sheet and then copy and paste the bar graph here. I will show you in another video how to do that. I did it for 7th grader already. But so if you're doing this by hard copy, if you print this out, then you can just draw your graph, your bar graph right here. I've provided that for you. Those that are doing this in class or virtual, whichever one, can click this and then see how it goes blue, and then you just delete that, and then you can insert, copy and paste the bar graph that you create in Google Sheets. Analyze your data. What story does the graph tell? What do you know about the effects of the independent variable and the dependent variable? What do you know about the paper towel compared to the amount of weight that it holds? Do you see a relationship? Below is the price of each. Goodness, the formatting is all messed up. I'll try to fix that in a second. Below is the price of each paper towel brand. Calculate the price per sheet of the paper towel. All right. So that's all messed up because I put bars right here. So I'll go fix that. What paper towels is the best bargain? Why? So when it says bargain, what it means is if I take the Bounty right here and it says it's $2.69 per roll, and I have the number of sheets, I need to figure out the price per sheet. How would you figure that up? My total rolls divided by my number of sheets gives you an amount. Take it to the thousandth place. That's the 0.000. 3 places past the decimal point, because you're going to find that they're going to be very close. And then it says right here, scroll up a little bit. It says cost rating. 1 is the most expensive, 3 is the least expensive. So figure out which one is the most expensive and put a 1, least expensive put a 3, middle one will be a 2. All right. What paper towel is the best bargain? So you could do it by cost. Yeah, you're going to find out which one's the cheapest, but that's not the best bargain. If they're all similar, then which one has the greatest wet strength and cost? The cheaper cost with the best wet strength would be the best bargain. So think about that, and then why. Write a conclusion. Answer your original question. Which paper towel has the strongest wet strength? Go back to your original hypothesis. Do you accept or reject it? I want to hear accept or reject, or I want to read accept or reject. Use actual data, real numbers to provide evidence of what you say. Identify any sources of errors. So a source of error. So let's say you got this chart up here and you're putting your data in, and one group has 200 grams, and then this group here has 900 grams, and this one has 200 grams. So that 900 is something's wrong. So where would errors occur at in this thing? Maybe this dried out. Maybe there's too much water and it broke immediately. So you identify the source of errors and make sure that's on there. Real numbers, real data. Don't just say A strongest and then you have no data to support it. Support it. I'm looking for support. Fill out your document. Use the data that I provide or do this in class, whichever one you have the option to do, and complete it and submit it. I have found out that Moodle likes to be submitted in Word documents or in PDFs. So if you are doing either, you'll have to submit it to PDF, or if you need to submit to PDF, if you go to print like this, if you're using a Word document, you see it says save as PDF right there. So that PDF, you can hit save as PDF and just give it a location, and it will convert your Word document to a PDF. So if that's what you want to do, that's fine with me, and I just deleted that. Didn't mean to do that. Anyway, good luck, and hope that helped. Where's my screencast? Please tell me that screencast did.